11.4, apply the Pythagorean theorem. Intro to geometry. So for those of you that were here yesterday, you know that we did 11.5. We're backtracking to 11.4 because I felt that this would be better for you to be in class for, and the other section from yesterday is a little easier just to like pick up on your own, pretty quick and easy. So we applied the Pythagorean theorem to a right triangle. And so when we have a right triangle, that means that one of our angles is 90 degrees. Then it has two legs. And the longest side over here, which is the one that is directly across from our 90-degree angle, is the hypotenuse. So each of the sides will be given a name. I'm going to draw another triangle so that it's not all crazy. So each of the pieces, it's not straight, have a name. So the two legs are A and B. The hypotenuse is C. Now ultimately, the letters don't matter. In a typical triangle, it doesn't matter. But when we're doing a right triangle, the hypotenuse is always C. Okay, so the Pythagorean theorem says that if a triangle is a right triangle, then the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Now, just hearing that definition, you're probably like, what in the world? Well, good news is the formula is nice and simple. A squared plus B squared equals C squared.
That's the easiest formula I've seen all year.
So, in addition to the quadratic formula, the distance formula, and the midpoint formula, I think those are the three that we've had, you now also have the Pythagorean theorem. It's the formula for it. I will have you write all of those things on your quiz on Tuesday, okay? And I will check it for you to make sure that they're right before you start using them and end up using the wrong formula. Yes?
Is it going to be like a question, or is it going to be like extra credit?
There's going to be like a question box for you to write them all.
Okay.
Let's see. Crispy. All right, so the problems that go with this say use the Pythagorean theorem, let A and B represent the lengths of the legs of the right triangle, and let C represent the length of the hypotenuse, find the unknown length. So the way I've just written it for you is the way that it will be for everything, always and forever. Right triangles, A squared plus B squared equals C squared. So they're going to give you two of them, okay? And now we can manipulate this formula. If I need to solve for side length A, I can do that by doing, okay, A squared equals C squared minus B squared. And then I would take the square root of both sides. So we would have A is equal to the square root of C squared minus B squared. Now, the one thing that's different, okay, when we were solving equations by taking the square root of both sides the other day, what were we doing? How was our answer written?
Plus or minus.
Plus or minus. Now, can I have a negative length? No. Jonathan shook his head. No. Okay? So, that means I only need the positive one. As far as actually solving, yes, it is positive or negative, just like it was with the stuff from the other section. But these are lengths, so it's only the positive value. Bless you. So, number 4. They give us B is equal to 3 and C is equal to 7. So you don't necessarily have to write the formula every single time. I'm going to write it probably most of the time while we're working, but A squared equals, nope. Well, since I've already manipulated this, I'm going to just use the modified one over here. So C squared minus B squared. So now I can plug in the numbers if I want. So A squared is equal to 7 squared minus 3 squared. Now, it's important to put parentheses around the stuff that's being squared, okay, especially if they're negative numbers, so that you don't get confused, because like I said, everything's got to be positive. These are lengths. So 7 squared is,
49.
so we've got 49 minus 3 squared is, so now A squared is equal to 40. But I'm not done. I've got to take the square root of both sides. So A is equal to the square root of 40. Now, obviously, I had already manipulated this formula up here. I could have made it go faster by doing it that way and just going straight to A is equal to the square root of 7 squared minus 3 squared, which would have then let me go to the square root of 49 minus 9, which is the square root of 40. So I can speed up the process if I already know that, but that's just because that one was already written, okay? Questions on that one? Six. B equals 5 and C equals 10. So, I'm just going to use the short form. A is the square root of C squared, so 10 squared, minus 5 squared. So it's the square root of what?
100 minus
100 minus
25.
100 minus 25, which is,
75.
yep, so it's the square root of 75. And again, still, if the things come out to be a perfect square, we obviously should give them like their actual number. But if it's something that's not perfect like these, we would just leave them. Eight. A equals 5 and B equals 12. So I've got A squared plus B squared equals C squared. But if I want to kind of like save a step, I can go ahead and take the square root so that I have C by itself. So I'll have the square root of 5 squared. And if they're positive numbers, I don't usually put the parentheses. If they're negative, well, they can't be negative numbers in here. What am I talking about? Disregard what I just said. They're links. So 5 squared plus 12 squared equals C. Because I already took the square root so that it's under the radical like that. So this is the square root of what?
25 plus
144.
140.
And so that's the square root of what?
159.
Is that a perfect square? Yep. Now, fun fact for you. This is a Pythagorean triple.
Oh, what is
It won't make sense till you take geometry. That's why I'm just saying it's a fun fact. A 5, 12,
Should I write that down?
13 is a Pythagorean
Oh,
triple.
I get it.
Don't spill it. I wanna be surprised
Explain it
whenever.
to me.
I don't
No,
get
I
it.
wanna be surprised whenever the numbers 5, 12, and 13. Oh my goodness.
No way.
3, 4, 5 is also a Pythagorean
I
triple.
get it.
Okay.
Supposed
So
to be
then what are
line
some others? He stuttered already.
5 plus 7 equals 12. 12 plus.
Bro, no. Stop
See, I get it.
I'm just giving you a fun fact. This is a Pythagorean triple.
I'm just saying-
You don't need to know that.
Explain it.
Purely just a fun fact. Never know. It might show up on Jeopardy one night if you're watching it.
I know.
Oh, I'm going.
I get it.
on Jeopardy,
I
no.
get it.
Be like, state a Pythagorean triple. Or the numbers 5, 12, 13 are what?
I'll be like, I know that before
They're
you.
whole numbers.
I was.
No,
You'll be
no,
stuttering.
no,
You'll
no,
be
no.
stuttering to say. You'll be like.
Hold on, one's scary.
Bro, I would.
Alright, so this one's a little bit more, or well, not a little bit more. It's different because now what letter are we solving for?
B.
B. See if you can tell me the modified formula for this one then.
Would it just be B squared equals C squared minus A squared?
Yep.
Oh my god.
It's just the same thing we're opposite.
John, they just hack it at this point.
Alright, so I'm going to go ahead and take the square root of both sides from the beginning. So B equals the square root of 25 squared minus 7 squared. Anybody know 25 squared?
Don't you put parentheses around
525?
Yep.
You can.
I guess 525.
I can keep the sign straight, but if you need to do that so that you don't accidentally square the negative sign, then yes.
Wait, what if we get another cookie?
You just want more cookies.
I do.
Alright, the square root, or not the square root, the square of 25 is 625, minus 7 squared is 49. Trying to speed this process up. Which is the square root of 576. Is that a perfect square?
Maybe.
Yes, probably.
Maybe.
Of course.
I'm asking, probably so. It is 24. This is also a Pythagorean triple.
Why?
Why don't you explain it to us in video?
Why
Explain
is
it to us.
it?
Why?
Is it 7, 25, and 25? Are they infinite numbers? Or is it like just
No,
a set?
they're all just basically perfect squares.
So how are they related?
Pythagorean triple is when you have perfect squares.
I get it.
So all of these are whole numbers, right? If I took the square root of 75, that's not a whole number.
Oh.
I kind of get it, but I don't get it.
Yeah,
like,
they just look like random numbers to me.
because there's a 20.
So I said it won't really make sense till you're in geometry, but
Yeah.
There's a 25 there,
just a-
there's 7 there, there's 24 there. That's all I know.
Harrison, therefore, be quiet.
the side links are a Pythagorean triple. If you look at the mu alpha theta banner on the back wall over there, you'll notice the M has 4 blocks, the A has 3, and the theta has 5 blocks. 'Cause it's a 3, 4, 5 triangle, like a 3, 4, 5. So it's a Pythagorean triple.
That one is
Which side?
The mu alpha theta banner, the triangle in the middle,
Oh, bad.
the big move.
the only sign over there.
I was thinking for that
Yes.
one.
Those are
I'm
math
looking at the
class
ammo, I'm like,
rules.
what the?
Class rules.
All right, I want you to try this next one by yourself. I'm gonna make one up though.
Oh, no, this is
I'm not sniffing your fingers. Stop.
Okay.
It doesn't even burn your mouth.
A equals 4 and C equals 10. What do we get?
B equals the square root of 84.
You agree? Square root of 84. Now, we can also use this. They call it the converse of the Pythagorean theorem. But if we're given 3 side lengths of a triangle, we can determine if it's a right triangle by plugging in the numbers and seeing if they're equal to each other. So, an example of that, 24, they give us the side length 9, 12, and 15. And so I can test to see if this is a right triangle or not by plugging them in. The largest side is always C. The other two don't matter. A and B can be interchangeable. So this is going to be A squared plus B squared equals C squared. I'm not moving anything to the left or the right. I'm leaving it as it is. So I've got 9 squared plus 12 squared is equal to 15 squared. What's 9 squared?
81.
It's 12 squared. 15 squared? 225. What's 81 plus 144? 225 equals 225. So this is a right triangle.
I knew it all along.
No, you didn't.
Why didn't you say it?
I was picking it up.
So good.
You got on the board.
26. 9, 21, 24. So I've got, I'm not going to rewrite everything, but I've got A, B, and C here. So 9 squared plus 21 squared equals 24 squared. So we got 81 plus, anybody know what 21 squared is?
441?
It is.
I did math.
24 squared?
No way.
Anybody know that one?
You gotta jump.
We should, because we've already done this one once today in our problems.
Have we?
Hang on. Shut.
Well, we did the reverse of it.
576.
576. So now 441 plus 81
No.
says
No.
522.
Why doesn't equal that?
They do not equal that, so this is not a right triangle.
Can we just put solution or no
Wait,
solution?
So does that mean it's a left triangle?
No,
Oh.
It was like left triangle.
because it's not solution, it's right triangle or not.
Yeah.
Figured out.
Because these could very well be side lengths of a triangle, they're just not side lengths of a right triangle.
God gave me.
Alright, are we good or do we need to see more?
No, now we're
Please
good.
give us the. I'm not good.
Make it like 4 problems.
I'll
No,
be-
she's
Give
not
me
giving
like
us like
five.
4
I'll be here
problems.
for like another
Give over you 36
10 or
problems.
5 minutes.
36. 36.
36.
3,
All even.
5, 9, 11,
With no lesson.
23, and 27. Now, I'm going to tell you if you go to check your answer in the back of the book, okay? I'm just going to show you an example. If the answer is that, say, b is equal to the square root of 8, the book is not going to have it written as the square root of 8. They're going to be writing it as 2 square root of 2. You don't know how to do that yet. We did not have time to cover all of that stuff. That's usually covered in Algebra 2. So I'm just letting you know, don't think that just because your answer looks different that it's wrong, okay? If you're not sure about one like that, number 9 is going to be written differently in the back. I can tell you by what the answer is. It's going to be written different than how you're going to write it. So just be aware of that. If you have a question, come ask me. I can really quickly look at it and tell you if you have the right answer or not.